with Chris Condron. He's a technical fellow at Event Stores and helping us take the database in new directions and exciting new ideas about what we should be able to do with such systems. And Chris has quite a long experience with event source systems, and
I'm officially old. I got gray in my beard, all that stuff.
I'm gray as well. Well, with messaging and event source applications, so we're going to have a series of conversations and have some fun with it. So today we are going to begin with the obvious topic: is why do we need event sourcing?
All right. So let me give a little bit more background. So Chris Condron, I've been working with message-based and distributed systems since the mid-90s. I started off in telecom, right when they were getting into voice over IP and package-based telephone switches. And so my first jobs were building, testing, and certifying those kinds of systems. And I did that all over the world for quite some time. And then I wound up moving into like big data systems and like insurance and banking and finance. And I sort of got away from message driven. It was much more data intensive stuff for a while. I met Greg Young, and he introduced me to event sourcing, and it really brought together the message driven systems I had started with early in my career with the application based and enterprise based systems that I was building for large financial institutions and insurance companies, and even medical imaging and things like that. And that's really how I got into event sourcing. And I've built a wide range of different types of event sourcing, message driven, and event driven systems.
So, as I said, we need to explain.
Why do we
need to
want?
explain me why do I want message-driven system or event source system, and if there's any, why do we need that today?
So I want to start by praising relational databases. All right. They pulled off one of the largest magic tricks in history, and it was fundamental and important for application development for years. If you think about it, when you write data, so a relational database, you build your third normal form, and you've got 30 tables, and you've got joins, or hundreds of tables.
Yep.
But when my application goes and update all those individual little bits and bobs, I can just put a transaction on it, and the database will freeze time, and it will update 30 different little bits of state, and then it will unlock time and give me back a result as if nothing had happened in the middle. And not just for my client here or my client there, but everywhere. My entire application can avoid the harsh realities of distributed processing, multi-threaded. I can just say, oh, we're all going to sync on the database and everything will be perfect every time we change something, right? I just have to get a database guy that knows how to turn on the optimistic locking or, how do I want to do my reads, right? And that works great up to a certain scale, right? And honestly, if you look at what Oracle and SQL Server and a lot of these guys have done, they've gotten that scale to be really, really big. But there's this hard limit. Once you start dealing with cloud applications, distributed applications, there's no way you can have a single application, a single source of truth that's running in, say, South Africa and Seattle, right? That's going to be able to do distributed locking and give you any kind of decent performance. right? As soon as you go over a WAN, as soon as you're in your cloud, as soon as you want to horizontally scale, or even before we get to the giant Facebook apps and Netflix and whatever, fundamentally we need a different model that's going to do this. So what's really, you see this in the whole microservices, decision locality, independence. You see it even in, giant systems where you start building independent apps that can run in different places and they have known synchronizations. Because the way you solve this is you make decisions locally on local data, right? So you can be autonomous in whatever you're doing. And then you share that with the other places. So you immediately move into message driven systems. You're not going to ship state. You're not going to, do a remote database sync. You're actually going to create messages, say, hey, I did this and you need to know about it. And I did that and you need to know about it. Right. And it's not like a command. I'm not telling you, hey, can I do this? I'm telling you, hey, I did this because I own my local decisions. So and then in those two different types of things are important. This isn't RPC. This isn't like a remote procedure call where I'm asking you to do something and you could say no. It's like, hey, I did this. I might need to roll it back. It might not have been okay that I did it, but it happened. My state now reflects that I did this thing, right? And so now I start getting my enterprise messaging buses, my distributed buses that are going to take the state from this application, put it on a bus so this application knows what the other ones were doing, right? So that's the next step is as we move out, we can't trust this magic to turn things on and off. And we've got to go to this decision locality. We've got to go to eventing systems, and that gives us event-driven applications. Because once I have a stream of facts that are coming out of something, and now I can even mix in external facts. Like you have temperature sensors, like you have stock ticks from the market. These all represent committed, completed things that happened. So now I'm dealing with an event stream of things that happened. Now, when we take an event stream of things that happened and we try to make that work with relational databases, we get into a lot of problems. Because a thing that happened, you could model it as I changed this table. I could throw change data capture on my relational database.
Yep.
But the problem with that is now I've coupled my application and my schema in these two systems together in a really low level hardcore way. It isn't, hey, I onboarded a customer. Hey, I sold a pair of pants, right? It's the invoice table had columns B, A, B, and C change by this amount. So I don't know what happened. I lose a lot of information.
Yeah.
And that's an important problem, but the real problem is now the invoice table in both systems must always match. I can't upgrade this system and then upgrade that system separately. Now they both have to upgrade together. Right?
Right. It makes me think because this is a known problem even outside of having data synchronized. If you think about ETL processes, it's the same thing. Every time I change my database, I have the BI team who's unhappy with me.
Right. Because these are fundamental problems in computer science. These aren't about this architecture. It's like as soon as we do this, Conway's law comes in. I want the team over here to be able to move and change things. I don't want, you change something now, everything breaks. Right. And that gets us into this public and private schema, right?
Yep.
I don't let other people take dependencies on my private schemas. I need to have these public schemas I share with. And so events become a public distribution between two private systems. And when you don't do that, you run into a lot of problems, right? And if you start doing change data capture, you start saving the internal states of your application in the application's private storage, you've coupled those in together.
Yeah.
So we really want the output, we want the decision to be what we record and what we distribute. And we might even record our decisions privately and then have a public decision that we want to share with everyone. And that's really what we want to advocate. And we want that storage, to be aligned with this architecture. We want a low impedance between how we store and think about things and the fact that we have all these messages and these systems and these flows,
Yeah.
right? And one of the ways I talk about is we don't want, a bucket model where my data store is, I have a database and I throw stuff down the well and I put a bucket in and pull it up. The bucket goes up and down. We want a flow pattern. I want to write it in here and it comes out over there. The same way my messaging queue works. And once we really embrace this distributed, event-driven system, we can allow it to be async. So now we're not coupled and we're not synchronizing everything as we do it. It's fundamentally asynchronous messaging. And now we can start doing horizontal scalability. Because if I just have a stream of events coming out, I don't know how many people are listening. I don't care how many people are listening. I can fan that out. I mean, you think about how they do, how the World Cup works, right? In soccer.
Yeah.
They have one distribution, they're fanning out to every TV everywhere.
Yeah.
They're not synchronizing, adding another TV at the end of that doesn't change how well they can stream the game.
Yeah, but then this fan out, because there are probably two things. I probably need some kind of scalability and having some kind of processing fan out to one or multiple processes, and it's something different than having something like, or I guess in my head it's different. Like, okay, I have this piece of information which is of interest for the rest of the world, and
Right.
everybody does something different with it.
Right. So what we do is we turn the distribution problem from a ETL BI problem into a messaging distribution problem. So we publish out on a system and we use something like, AMQP, and we let people subscribe on topics. Do you care about this? And so now all of a sudden the infrastructure people for messaging deal with the distribution. Now, one of the challenges this brings up, and this is why your impedance matters, is in order for that to work, what works really good when you do that is having an immutable series of history, right? And not having to know the back end state to recover.
Where does that immutable
Well,
log lives?
it has to start with your application. So we want event sourcing as our backend storage pattern for our app because it uses an immutable append-only log of events. So now these problems of how do I support and recover these giant distributed systems becomes easy, right? I can create a series of guaranteed ordered messages with a single restore point that lets me recover and know. So if anybody got to message 9,000,002, they can cache it. And they know the only way it's going to change is that they can message 9,000,003. Right? This ordering solves so many distribution and cache invalidation problems. Because everyone can trust to where they got to.
Yeah, ordering inside my app.
Right. So you want to do ordering inside your app, and then you want to do a public ordering for what you publish. But once you have the ordering inside your app, the public ordering is easy. And then once you have the public ordering, your caching, your fan out is easy, right? So if you make it turtles all the way down, all of these really hard problems with failover, scalability, and distribution gets super easy. But you kind of have to up your game internally, right?
Um,
So let's talk a little bit about if I was doing like an account transfer internally in my app in a relational database, I would write a transaction and I would debit this table and I would credit this table at the same time, snap, and we're done.
yeah, that works within the bank, probably.
Within the bank. Well, any bank that really does that, I'd be really worried about. But I also know from experience, a lot of them actually do this.
They
But
do?
in the event source system, what we're going to do is we're going to raise an event on the source account saying reserve funds. And then we're going to raise another event once that succeeds on the target account saying incoming funds. And then we're going to do a final event to say, transaction finalized. So rather than doing one locking, I just break it out and I say, I'm really doing three things. Make sure I can get the money from here and I reserve it. Make sure it's valid to apply the money here because the target account could be locked.
Yep.
And then once I've done that, then finalize it. So rather than this lock, I do 1, 2, 3 in time. It's not that big a difference. But now I've got a time sequence. I've acknowledged time in my application, and it's really easy to publish a single public funds transfer event because
Yep.
they don't care about my internal ordering. I can just publish funds transferred and we're done. Anybody wants to read that because they're not inside, we'll just get a summary account 1, account 2, amount transferred, this amount. Boom.
Yeah, and I guess if you design that carefully, because there is probably a design issues to take into account. But if you design that carefully and you have like that one event that is of interest to the rest of the systems, you can change things internally.
Exactly. I could start off with this model where I use what I call a canary system. So this, just applying the three events says that you've got an implied recon that's going to go through and something goes wrong, it's going to check. But I might say, hey, these transactions are getting more complicated. I want to do a deliberate process that has 5 events to pre-clear both accounts, run it by an approval, like maybe a transfer over $10,000 needs a sign off. But my public event of the transfer happened doesn't change. Or maybe I add a field to it to saying, here's the approval code.
Yeah. So
Right?
so that's interesting because with that you get stability on the outside and quite some
Flexibility on the inside. Yeah.
flexibility on the inside of doing things differently or just adding new requirements that are coming in.
Right.
Like, okay, it's a transfer over that kind of amount. We need to do, I don't know, a clearance check about
Right.
or call the authorities.
Right. Well, and so then you have your internal flexibility, but you also have this horizontal feature scale. Like suppose I want to do, one of the things I like to talk about is money laundering.
Yeah.
Because all money, the actual crime of money laundering is structured, is payment structuring. So it's deliberately taking your payments and making them non-reportable. So if I wanted to add a monitor for money laundering, I could put it outside the system and I would just listen for the transfers. And I would just have a rule saying, well, if I see transfers within 10% of if I have a certain volume of money moving and none of it's getting reported, or it's really close to the limit, but always under and never over, then I can have that flag and create events on money laundering. And that whole system can be built by a different team with no impact on the internals. And I can scale out more consumers who can be listening to these transfer events because it could be internal transfers, external transfers, right? And so that gives me a federation of systems with this really powerful horizontal scalability.
Okay, that's what you mean by that. Okay, but that does. You, I know a lot of people who if they would listen to that would say, okay, I have like oh, the good thing in your sample is that the team that manages the money laundry
Yep.
detection, they can be really specialized in that domain.
Yep.
They can talk to people or have access to business people who are specialists in that. So, and it doesn't bother the team who needs to know about how do we make money move from one place to another.
Well, I mean, there's a two-level aspect of design here, which is really nice. So the money laundering team and the account management team are going to need to agree on a public schema
Yeah,
for the public events that go between them, right? And they're going to need to agree about responsibility. So they're going to need to agree that the transfers are handled and approved internally to the account management team. So they own that. And therefore, any information the money laundering team needs to know about the transfers must be present on the public interface.
yeah,
So you divide up the responsibility, you define your interface in messages, and then the two teams can go away. So then, when I'm working inside account management, I have a spec saying I have to share this information publicly, but I don't. But whatever I want to do internally is fine. I don't need to worry about money laundering when I'm working internally if I've got a strong spec. And the same is true on the money laundering team.
yeah.
But I think you were going someplace else. So,
Oh, I was more going about. I know of people who when we talk about messaging and different team owning different part of the system, they want to be sure about what happens in the how the system work, because I mean it does. And we're on an event-driven architecture now. It's not even sourcing yet, but um,
well, we're assuming that inside the two apps, it's event sourced.
yeah.
So
But
each
what
app is
would
event sourced and the system is event driven,
yeah?
right?
But what would be the difference inside the app? Um, do I get the same benefit? Because if I'm even driven message based on the whole system side, it does allow a few nice feature on scalability
Yep,
and scaling and adding features. The question is, does event sourcing then give me the same kind of advantages inside?
it does. So, and it makes it a lot easier. You can wrap a legacy system in this pattern. If you have one, you've got to do it. But it's a lot of work and it's going to have a lot of limitations and it's going to be really ugly to make it work with this distributed pattern. Whereas if you have an event source system, it's really straightforward. I've got the history. Because think about this. So we've got both these systems running, but let's talk about a third system like the month end reports, right? The month end reports are going to take output from both of those systems. And eventually, as in all software, the month end reports are going to die. Systems are going to get reset. Something's going to happen where you need to rebuild the month end reports. If you have a traditional relational system, rebuilding that state in the month end reports is going to require either a direct link or a custom thing that you build to send it, or an event source system, you just replay your history and they can do it. Like, suppose the reporting system had a bug in their code and they realize something's wrong and they need to rebuild all these reports. If you're fundamentally event sourced, you just go back and say, okay, I move my checkpoint back to here and I ask for a replay and everything rebuilds.
Yeah, what I had is like um, um, the an old system a legacy system, and they were getting numbers out of that. And at one point, okay, for 2010, so many of this kind of occurrence in the business. That's good. That's bad. Some KPIs,
Yep.
and then of course someone changes say 2010. Um, Someone changed the data in the database. Oh, I made a mistake, so let's correct the mistake. You got a support call, and you have like the super user changing the data in there, and then 1 year later, oh, we lost that report, that PDF. We just take the number, and the numbers doesn't match.
Right. And the business hates nothing more than when the numbers don't match on their reports
Yeah,
when you rebuild them. I mean, they suddenly lose all the confidence in the system. So by building an event source system, you're aligning your development practice and your storage and your team with the realities of distributed systems.
yeah,
Because, and that's, so everything is message reading. We take that timeline and we make it explicit,
yeah,
right? And when we have to do changes like that, we can put in retroactive events, but it forces us to model them correctly and deal with all these things correctly.
yeah,
Now, of course, if you have to, you can always break glass and change things if you need to. But fundamentally, event sourcing makes your life so much easier and faster. Because what you're really doing is, one of the things I talk about is um, you can use the factorial of the number of related components that are stateful in a system to model complexity of software. So when I'm working on a component, the complexity of fixing a defect in that component is equivalent to the factorial of the number of other things in the system I could break.
the incoming or outgoing coupling, you mean?
Yes. Right. So in that case, the developer who made that change in the database forgot about the coupling to the reports. He didn't take that whole subsystem into account. Right. And as you know, with factorials, they go up really fast. Keeping track of one or two things in your mind is easy. What 5 factorial is 120 possible interactions that you've got to keep straight in your head as you fix something, right? So what I say is that n plus n factorial is always larger than n factorial plus m. So people get really worried about how many moving parts do I have in the system? To always keep it simpler, have one thing. But the truth is that a system which has a dedicated flow with external messages and has an input and an output, it's far better to have more small components that do one thing and worry about a low number of things than have bigger components that are tied in all these weird ways.
Yep.
So, and then you build it because we've got the log and we've got this ordered series. Now, even with a large number of small components, recovery, high availability, failovers are all easy. Like, how do you truly fail over a data center with a big database? If you can do sub 5 millisecond disk replication, sure, you're good. But if you can't do that, failing over large databases and the amount of data lost and the corruption risk in the data loss and in keeping all your systems like synced as they fall over gets to be a nightmare.
Yep.
With an event source system, I've got one position, my checkpoint in the all stream that represents where I'm at. And I build all my systems so they can recover from a checkpoint. So we fail over to here. I can tell you for sure we lost 3 events on the all stream. You know whether or not that's in your SLA. All of your systems can rebuild their states. And then you can do an action item to reapply the 3 missed messages or to acknowledge people, hey, we had a failover. But the restoration of state, because you've already made it distributable and recoverable,
Yep.
right? Because all state outside of your event source system is derived state. And if we know that all of our derived state is recoverable by replaying events in a known order, in a known sequence, with a known checkpoint, it's easy to recover. You know,
And
yeah,
and also probably, that's the fact of distributing thing, is the resiliency of the system. There is
right,
no one gigantic database that could happen to fail at one point in time,
right,
and it does always happen. And we know distributed
yep,
system fails. That's the nature.
right,
Uh, if you have like this one gigantic database, okay, everything is down.
right.
You're done.
Well, I
Which
mean,
might,
you're still going to be down with the, you know, if your event store database fails the same way. But the thing is that your road to recovery, you're because you've modeled your state concretely. I don't have all these applications that are also failing over with unknown states. Because the problem is generally when you're failing over a huge system, is everyone has a slightly different view of the universe, and they're all relying on the magic trick of state is perfect.
yeah,
And once the magic breaks, you're done. Whereas with an event source and distributed messaging system, you've modeled in, we know how to restore state, we know how to sync, we know things aren't always in line. So because you've sort of upped your game just a little bit, all of the hard problems become really easy. Does that make sense?
okay, it makes sense. Um, Let me summarize what you said in the past half hour now. Okay, we know we are. I mean, the world is going to distributed systems
Yep.
to have all the goodies of distributed system. And if you look at what we have on in cloud provider, they only have like distributed systems.
Yes.
That's what they provide. They
Yep.
provide a ways to host them, and having them communicate. And if you look at what all those providers give, they all give some kind of ways to communicate information from A to B.
Yep.
Think SQS,
Yeah.
Event Hub, stuff like that.
You know,
So
Kafka. Yeah. There's.
that problem,
Yeah.
Kafka, that problem is solved. The question is, how do we build our application? What kind of how do we build? How do we store the information
Right. Well, no,
inside our
we
little,
want to build our applications to align with this reality and this architecture. And so
voila.
part of
Yeah.
that is if we store our data using an ordered log that matches the ordered log they're going to distribute, all of a sudden we get all the benefits of being aligned with the fundamental architecture of what we're doing in the cloud.
So lowering some kind of impedance mismatch on system level then, huh? I'm not even talking about code and domains and models and stuff
Right,
like that, but on a system level, you lower the mismatch between
right.
how do I distribute this information and how do I produce it, or how do I store the
Yeah,
produced information.
yeah. Good design is fractal. So we do this at the macro
Yeah,
scale, and then inside, and then inside, and inside, all the way down. We use the same pattern. You know, this is the same
yeah,
pattern that the pattern we're talking about is the pattern that's inside that relational database we're talking about. They do the same
yeah,
thing in the database. It's the same pattern that happens on the processors that are running the code, right?
yeah. And that's maybe the topic for another thing, but
Yeah,
actually database all do the same. They have their log and they append and they transform that into tables and rows.
yep,
So there's something similar there, but it's hidden from view, of
right.
course.
So by letting go of this magic trick that we used when systems were smaller and accepting that on a larger scale, we need to align our development process with what's going on. And I actually find that once you change your mindset and you start building applications in this way, I know of very few people who, after they've done that and they've built successful systems with the pattern, who ever go back. I know
I'm,
some people who don't make the leap, but
yeah,
I don't know anybody who goes back.
I'm one who don't want to go back. I'm willing to work on systems who are relational or documents of stuff, but there's always a part of me wants to, yeah, let's shift that to the other
Yeah,
one because it gives freedom. Actually, the main thing for me there is the freedom. You know, it's like I'm thinking about this little part of my system. I don't care about the rest. I do care about the rest of the
You
system,
do,
but
but you can
I,
focus.
I
You can
don't
break
have to take it into account in the same way.
right. The same way I talked about the teams, like the fraud team and the account management team, don't have to care about it. When I'm building an account aggregate, I have the same thing. I know what messages are coming in. I know what messages are going out. I don't care about the other aggregates.
Yep.
Right. So my microservices and my aggregates, my objects, it's all the way down. I can focus, solve a problem, test it thoroughly, know it's going to work, trust it, move on.
Yep.
All of that pain about the coupling and the side effects, even inside my own system, go away. And once you just train yourself to that 2-level, who has responsibility, what needs to be communicated, what goes on inside those 2 levels, right? One's inside here and one's in between. And that goes all the way up to your whole
Yep.
system.
Yep. Yep. But it does need that magic leap of changing your
Right.
mindset and thinking in other ways.
Right. Because as long as we're coupled into our state is magic and is all coupled together, then we can't distribute. We can't
Yep.
go back in time. We can't recover. Well, we can, but it's hard. And it's like, and the cloud guys understand how to replicate a log, right? It's all really well solved problems. You can just go and buy stuff off the shelf that'll give you topic based pub sub. Buy stuff off the shelf that's going to replicate your logs. Buy things that are going to stand up your caches, right? And all of a sudden, all these hard problems are like, no, this, put them together. I can test them. I know how they're going to work. And invention is the mother of necessity.
Yep.
Right? People say it's the other way around, but in truth, if Jared Diamond, Guns, Germs, and Steel, if someone comes up with a better mousetrap, everyone's got to use that mousetrap. And fundamentally, teams that build event-sourced applications in the cloud are building better applications easier. And they're going to take over the industry because it's easier to do, it's easier to build, it's faster deployment, better scalability. And so eventually that's where everything's going to go, because you will not be able to afford the pain and trouble and strife of traditional applications if you want to keep up.
Yep. But I guess there's still some room for a traditional application. They do exist. They have their value as well. So,
And they're
but
going to be there, and you wrap events around them and they work. But going forward, the new stuff people are building, that's not going to be the way to build those.
the same shift that happened 40 years ago when database appeared.
Exactly. Right. I mean, building an application today without a relational database, right? That same jump is happening again.
Yep.
Right. And you see all these synergies, right? So traditional 3-tier apps really need a database or you're going to be in trouble. Relational database model. If you're doing something with like JavaScript, or something, in that frame, MongoDB is going to work really well for you, right? Because your documents are in JSON and it can be really well aligned. If you're doing a pure distributed event-driven system and you have millions of key values to update, you're going to want a cloud key value store, right? But if you're building an application in a distributed system, you don't want to have all your state available to everybody. For my app, I'm still going with my private state. I'm going to want to be event sourced and aligned with my messaging patterns.
We need to talk next time about every messaging patterns out there.
Yeah.
Okay. I think we can stop here for this first.
This was great.
Yeah, thank you. I learned some stuff again.
Awesome. And, as always, I have a very opinionated view of the world, and your mileage may vary.
Oh, it's opinionated, but I know it's loosely held. So
I got lots of scars. I see this scar here, that scar here. I learned most of this through the School of Hard Knocks and putting systems into production.
Yeah. Oh, we all have our scars.
Yep.
Mine are somewhere else. Okay, thank you,
All
Chris.
right. Thanks.
Bye.
Bye.